I think now I'm recording the class. Yes, I believe so. So remember that the error is one of the most significant aspects of numerical analysis. And we always have to actually do some error analysis when we want to predict or estimate any kind of numbers, okay? Errors may occur at any stage of the process of solving a problem. And of course, by error, we mean the difference between the true value and the approximation values, or the approximated value, okay? So if we want to actually picture this as an equation, error is equal to true value minus the approximate value. And if we go back to this, remember that we wanted to explain this with the whiteboard. I'm just repeating this for my second class. Sorry about this. So remember that the true values are always pi, for example, pi, 1, 1/2, and e to the power 1. This is the exponent, remember. These are examples of true values. Another example of true values are the fractions. So 1/3 plus 1 is equal to 4/3. This is the true value. But then when we apply the rounding off the approximation, so 1/3 plus 1, we have that is 1.333. And this 3 actually continues in an infinite way. So this is an approximation when we cut off or we round off to 3 decimal digits, okay? And then another example is when you have pi plus pi equal to 2 pi, and then this is the true value. But pi, if you actually use your calculator, is equal to 3.141592 65.4. This is the approximation. And pi, the approximation we always use to calculate areas of a circle or any kind of operation that involves the value of pi, we always use 3.1416. And additionally, if you have observations such as the temperature in each day of the year, so you remember that we start with the winter and then we actually start the spring, we reaches the summer, and then we have declining down back to the winter, which is the fall and the winter. And then remember that the observations are the black dots, and the Fourier curve is going to be equal to the approximated value. So if we want to quantify the errors, so we will have actually predict the value using my observation for any specific day of the year. That's going to be my approximation. And we have to compare the value with the real observation. And we estimate the error. And we can estimate the error for each of the observations that we want to compare. Later in the class, we are going to use what we call some error metrics. And these error metrics are going to include some of the mean square error, the absolute error, some other errors that we are going to be using later in the class. So do you have any questions? I think you already had some question answer. This was for my second class, so I'm sorry I had to repeat that myself, not in purpose. So we go back to the type of errors. So we know the concept of error, but we also have to identify where those errors come from, right? So usually we come across with the following errors types, okay? So the first one is what we call the inherent errors. These errors are errors involved in the statement of a problem. When a problem is first presented to the numerical analyst, which in this case is you or myself, it may contain certain data or parameters. And these parameters, these data, also are, determined by any physical measurement. And they will probably be different from the exact value, okay? Those errors are what we call inherent errors. For example, if I ask you, for example, let's use our eyes, for example. I have, for example, in this class, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 people, right? So if we want to use a device, so let's use our eyes, okay? So this is gonna be our device. So I'm gonna use my eyes to actually do some analysis. So I see that now we have more people, but it's fine. So I would say like I say that this guy that has this actually taking out his buggers. So this guy is about 1.74 meters tall. Quiero decir que tú mides más o menos como 1.74. So that's my guess because this is my device. This is my error. So right. So I'm saying now because I see this guy now. What's his name? Montoya. So I said that Montoya in this case, I would say like you are 167. 167. This is just a guess. So I have 174 and 167. And finally, I would say like this lady here in the middle, she's about 164. 164, 167, and 174. Okay, so this was my guess. But in reality, please, you tell me how tall are you? Dime tu estatura. Dime tu estatura. Tú tienes que activar tu micrófono, creo, para escucharte. Si no, escríbela. Si no, no hay problema. Escríbela ahí en el chat.
Profe, ¿se me escucha?
Sí.
Ok. Yo mido 1.86 más o menos.
Mide 1.86. Wow. So 186 minus, I would say like 186 minus, my guess was 174. So I had 0.6, almost 12 centimeters wrong, right? Yes, 12 centimeter wrongs, right? Yes. So that was my error. So the second, I said like it was 164, right? For you. Montoya, ¿cuánto mides?
1.76.
166. So what's my error? So how much was my error? Was 6 and 6. It was the same error actually, if you think about it. So 12 centimeters. And lady, I said that you were 160, I think 60, what's that? I said 60, let's just call it 62. I don't know you. How tall are you? You. How tall are you?
1.52.
So my error now it's here. I have 8, and then I have 10 centimeters error, right? So that's my error, right? So I have different errors actually. My errors actually was always above 10 centimeters. So but what I'm saying that my inherent error is actually about 10 centimeters. Why? Because my device of measurement, it's only my eyes. Solamente uso mis ojos para poder medir su estatura, que es algo muy poco porque ni siquiera están, digamos, al lado de mí, ¿no? Entonces, es algo completamente erróneo. Por ejemplo, otro ejemplo sería la edad. Por ejemplo, yo podría decir que, lógicamente, yo soy el más grande de ustedes, pero si me voy aquí y digo cuál es el más grande, por ejemplo, diría que los más grandes del salón los vería, vamos a ver, yo creo que Montoya es el que va dando como el gatazo. Entre Montoya y aquí el compañero son como que los más grandes. Y yo les calculo por ahí unos 21. 21. ¿Qué tal? ¿21 Montoya?
En abril 21, profe.
Bueno, en abril 21. ¿Y aquí el compañero cómo te llamas y tu edad? ¿Aquí estoy señalando? Sí, tú.
Sí, 20, profe.
20, Pacheco, ok, 20. Entonces, digamos que mi error más o menos fue de 1 centímetro, ¿no? Mi error. Yo, por supuesto, la más joven, aquí mi compañera, que ella se ve como de 15. Entonces, pues lógicamente, mi error es bastante. ¿Cuántos años tienes? Te aseguro que tienes más de 18, entonces.
19.
19. Entonces, ahí está. Entonces, vemos cómo solamente la medida de nuestro ojo es un inherent error. ¿Por qué? Porque es un aparato que me permite, ¿qué cosa? Que me permite únicamente medir, en este caso, ciertas características físicas. Así puedo hacerlo con una báscula, lo puedo hacer con una cinta métrica, lo puedo hacer, por ejemplo, cualquier que sea más preciso. Una cinta métrica uno de estos aparatos que miden con láser.
Pues el que mide con láser, ¿no?
Exacto, medir con láser, porque digamos que te miden tu estatura, ya ven esos foquitos que tienen así, unos foquitos que suben y te llegan a la estatura. Entonces, son más exactos que lógicamente medir con una cinta métrica en un consultorio, por ejemplo, ¿no? Entonces, si tienes una báscula solamente a puras pesas, que son pesas de las de, ¿cuál que les gusta? Las pesas estas que utilizan con barritas y que vas aumentándole pesas a una báscula digital, ¿cuál creen que sea más precisa? Lógicamente una báscula digital, que la pesita que vas moviendo así como para calarle, ¿no? Entonces, es más preciso.
Con razón las básculas que estaban en los hospitales no eran exactas.
Exactamente, ¿no? Porque pues eran así como que parte estaban ahí como tirándole ahí a ver cuánto subías o bajabas, ¿no? De peso. Entonces no eran tan exactas, pero ahora ya cambiaron las básculas digitales, entonces ya tienen un inherent error menor que el que podrían tener las otras básculas. Entonces eso es un inherent error. Usando un aparato que tiene una exactitud, una precisión específica, y estoy, ¿qué cosa? Midiendo una característica, ya sea estatura, descarga de agua, estoy midiendo cualquier tipo de variable física, me van a introducir errores, porque ellos difieren en realidad del error exacto. Por eso cuando compras un aparato siempre te dice precisión más menos 0.01 centímetros, por ejemplo. Because they need actually a precision. So that's the inherent error definition. And now, we go to actually the second definition. The second definition is then what we call analytic error or analytic error, okay? These errors are introduced due to transforming a physical or mathematical problem into a computational problem. Once a problem has been carefully stated, it is time to begin the analysis of the problem, which involves certain simplifications or assumptions, okay? The functions involved in mathematical formulas are frequently specified in form of infinite sequences of series, okay? So this is another type of error. So now we have all these observations, all the weights of this class, right? So we have a list of observation of the weight and the height of each of you. And then I want to actually express it by using a mathematical operation or using the computer, right? So in this case, when we transform any physical problem to a computational problem, we will introduce analytical problems. Why? Because we always depend on the availability of the computer in terms of operations. For example, if you want to analyze some expressions, so this is what we call actually analytic errors. For example, for me, I'm saying that the sinus of x is equal to this series. So this is going to be actually an infinite series. So if you see this one is x minus x cubic divided by 3 factorial plus x fifth divided by 5 factorial minus x seventh divided by 7 factorial plus this is going to be x9 divided by 9 factorial, and then we go infinite in series, right? So if we compute the sinus, instead of using this infinite formula, we compute the sinus by using only the first 4 terms. I just cut off this expression. So I will obtain certain error, right? For example, let's just do this example, this operation, sorry. Change your calculators to radians. Cambien su calculadora a radianes. So just to make sure that you are right, so calculen el seno de 5, por ejemplo. ¿Cuánto les da en radianes?
Menos 0.958. 58, 92, 42. Ajá.
Exactly. So that would be the sinus of 5 in radians. So, but now I'm actually asking you to use this formula to compute the sinus of x. En lugar de utilizar el seno de x, utilicen esta fórmula para calcular el seno de x. Sustituyan x, que en este caso es 5, in these 4 terms. It's going to be actually completely inexact. So don't get surprised, don't worry. Just do it and let me know the result. So it will be equal to 5 minus 5 to the power 3 divided by 3 factorial. Let me just find factorial in my calculator, but I don't think I have it. I should have it. It's funny because I cannot find it. Oh, right here. So factorial, and then plus 5 to the power 5 divided by 5 factorial minus 5 to the power 7 divided by 7 factorial. So what's the result? I already have it, but I want you to calculate that because it's important for you to also be active.
En decimales me dio menos 5.2926.
Exactly, minus 5.29266. So you see that the error in comparison with the real sinus or the sinus of 5, so it's very different, right? So there is actually an error of about 6.25. That would be the error of this operation. So it's actually a lot of error. So, but anyone that wants to solve this operation, so we can actually add more terms to get a better estimate of this. So what I'm asking you is actually obtain it to the x13. Obténgalo hasta el valor de 13. Si se dan cuenta sería 7, 9, 11 y 13. 7, 9, 11 y 13. O sea, se van a agregar 3 términos. Agréguenle, por favor. En realidad, la respuesta óptima está al agregar 14 términos.
Pero ahí sería más, menos, ¿no?
Sí, siempre es más, menos, más, menos. O sea, aquí sería
Ok.
más x9 sobre 9 al factorial. Menos, no sé si el 11, ¿no?
Ok.
X a la 11.
Hasta el 13.
Hasta el 13 por ahora, sí. Porque
Queda
es
menos 0.9375.
da menos
Sí.
0.9375. Ok, vemos que el
Sí.
error se redujo considerablemente solamente al agregar 3 términos más.
Profe, seguimos trabajando con 5, ¿verdad?
Sí, claro.
En realidad, ok, a ver. ¿Por qué no?
A ver, agrégale el compañero que ya lo hizo. Agréguele 2 términos más. Sería entonces, este fue para el 13, agrégale sería el 15 y el 17.
Me dio
Ya no
menos
me deja
0.
poner más.
¿Qué?
¿Cómo? ¿Cuánto les da?
Menos 0.9587.
Okay, so we now actually know that the error, if you think about it, minus, you said minus 0.9587 minus, actually it's going to be plus 0.9589. Oops, 0.5. So it's going to be equal to the error is going to be equal to 0.000224. So it's actually a very small error. So it's 30224. So the error is actually minimal. So we see that this is actually how we introduce analytical errors. When I want to actually transform any physical measurements, or just imagine you're actually doing an analysis of your mechanical engineering. If you're doing some actually like spectral analysis and you have a sinus function in general or electrical engineering, so you'll see that you see that you can substitute any of these values, but using a series. For example, Fortran, in the old very old version of Fortran, so sinus of x wasn't available as a function, so you have to use one of these series. So when we transform from any physical value of like sinus of x to any computational problem, so we'll see that we have this kind of situation. So we use until the 17th power to obtain an error of 0.002. That's actually a very good estimate. But if you want to actually do it, if you use 14 terms, you'll see that the error is actually incredible minimal. It's very, very small. Okay? So we also have a lot of examples. So if we want to actually make a transformation of this value, like exponent of x minus x equal to 0, we can actually do it using this expression. But then you'll see that you will find, again, similar error of this. So just to make this expression, to quantify the error, let's just do this type of calculation. Okay, compute exponent of 2.7. Let's make x equal to 2.7. So compute this. So exponent, which is the exponent, is the exponent of 2.7 minus 2.7. So it's actually 12.1797. Right? But if we use actually this expression, how much we obtain. So it's 1 minus 2.7 plus 2 divided by 2 factorial plus 2.7 to the power third divided by 3 factorial. So how much was that? Anyone?
2.58.
Exactly. 2.58. We'll see that the approximation is still not good. So we go back to what we say, okay, we have also analytical errors because we see that this approximation is not even close to this approximation, right? So this is something very, very important to actually understand, okay? So just make, do you have any question about this type of errors? ¿Tienen alguna pregunta de los errores analíticos? ¿Vieron cómo se introducen como tal cuando llevamos aproximaciones de operaciones que envuelven, por ejemplo, fenómenos físicos, operaciones
no
como
escuché bien lo
series?
anterior. ¿Podría repetirlo otra vez?
Pregunté si tenían alguna pregunta sobre errores analíticos. Y de ahí dije que una de las cosas que vimos aquí es que nosotros transformamos cualquier cantidad tipo física, ya sea una lectura de una onda, sea una lectura de cualquier tipo de representación y queremos llevarla a un esquema computacional, tenemos que hacer simplificaciones, ¿cierto? Entonces, para hacer simplificaciones nos basamos en series algunas veces. No solamente en series, puede haber muchas formas, ¿no? Pero podemos basarnos en estos. Caemos también en el mismo detalle en que si aproximamos por una función, aproximamos como lo vimos en el whiteboard, ¿se acuerdan? Si lo vemos en el whiteboard, decíamos, bueno, ¿saben qué? Pues podemos también aproximar una función, unas observaciones de temperatura, los podríamos aproximar a través de una ecuación. Entonces también es un error analítico porque tengo una ecuación que me va a describir observaciones. Pero como las observaciones tienen una variación, una desviación con respecto a la aproximación que yo propongo, que es una ecuación, no sé, una parábola que yo le quiera dar un valor, entonces ya aquí ya hay otro error analítico. Entonces esos son los errores analíticos de los que estoy hablando, ¿no? De esa índole. And then I'm going to actually go and define the last error. So the last error is what we call actually round-off errors, okay? And then this is actually very easy to understand. You know that when we have the pi value, we always actually apply the round-off procedure, right? If we want to round off a number, so we say like the value of pi, remember, was equal to 3.14, 15, 92, 60, 65. And then I give you an assignment. So I'm going to give you an assignment, and then Galmici and Montoya, because they are actually very good friends, so then you start doing the analysis of the assignment. And then somehow Galmici said, okay, I'm going to use only 3.14 for pi. And then Montoya says, okay, I don't like your approximation. I'm going to use 3.1416. And then Navarrete Peña dice, ¿sabes qué? Pues a mí tampoco me gusta tu aproximación. I'm going to use 3.141592. So which one do you think is going to have more errors? Galmici, Montoya, or Navarrete?
Navarrete, ¿no?
No, because Navarrete used actually more decimal points, more decimal digits.
Sin ofender.
Galmici is the one that is going to have more errors because Galmici said that pi is equal to 3.14. Montoya said like, okay, I'm going to use 3.1416. But then Navarrete said 3.141592. So he's using a more extensive approximation of pi. So he is the one that is going to be the one with more errors, Galmichi, right? So then Navarrete is the one that is gonna actually have the better a better approximation. Okay, so that's when we are applying the round off effect. So we have to use this type of error happens a lot when we are reading or we are actually taking notes from a device or a volume or a weight using a very old scale. So those type of errors usually happens when you have to, apply the round off or the redondeo en tus operaciones. Additionally, each of the computational programs that we were going to use here, such as Excel, Fortran, or R, have capacity of numbers, right? So in this case, we also have to be aware of these errors, because every time Fortran or R perform any operations such as addition, subtraction, multiplication, divisions, or exponentiation, we see that this is actually a operation that introduces certain amount of error. Oh, Galmichi, sorry, man. So sorry about that. So those errors always happens because we are applying redondeo. We are applying rounding off procedures, so we're rounding off calculations. That's the easiest error to understand. Cada vez que calculamos, que redondeamos, es como cuando vas al Oxxo, ¿no? Tú dices, no, pago no, pagas 44.75 pesos. Y cuando te dan el cambio, te devuelven solamente 5 pesos de tus 50, ¿no? Porque dices, ¿sabes qué? Oye, y mis 25 centavos, antes te los daban, ahora ya no. Pues ahora ya ellos ocupan el error a su favor, ¿no? Ya todos los 44.75 los redondean a 45 y te devuelven 5 pesos. Entonces, that's one of the definitions here. We actually using errors that involve rounding off. Okay? Do you have any questions about the type of errors? ¿Alguna pregunta acerca de los tipos de errores?
No, profe.
Okay, good. You sure? Anyone else with any kind of doubt or problem, frustration, intolerance?
Profe, yo nada más tuve una duda en los errores analíticos, no en el concepto, sino en el ejemplo, pero ya me quedé con la duda. Lo que pasa es que no me daban los resultados que los compañeros estaban dando, entonces no sé si no capté bien la instrucción, si era calcularlos en radianes, las operaciones.
Así es, todo es en radianes.
Ah, ok.
Okay, so any more questions? Remember, you will have the slides, you will have the presentation, so you can actually go through it, read it again, and then just, if you have any question, please just let me know next class, and I'm, more than welcome to give you my feedback. Okay.
Profe.
Yeah, go ahead, Pérez Calderón.
Profe.
Yes.
La información que está en las diapositivas, ¿la saca de los libros que está en las recomendaciones o la saca de otro lugar?
I take some of the, I take the definitions, but of course I have to actually, how can I say, I have to paraphrase the information. I just change the information because I don't want to just copy and paste, right?
Okay.
But in general,
Gracias.
if you go to any of the books that I give you, so you'll find that the definition is pretty much the same.
Okay. Gracias.
Okay, so now let's go and quantify now. Okay, I'm going to ask you these questions. Give me the definition of error, because I already tell you the definition. Anyone who can tell me the definition of error? It could be in Spanish, don't worry. If not, I'm going to pick someone.
La diferencia entre el valor real y el valor aproximado.
Exactly. So that's the difference. Sorry, that's a difference, right? It's just a differentiation of the exact value and the approximate value. So essentially, we can actually say that there is this formula. So error, which is characterized as delta, uppercase delta, is equal to the exact value or the true value minus the approximation. Easy peasy, right? Piece of cake. So once you know that this is the real value minus the approximate value, so it's easy to quantify the error, right? So, and then here we're going to have another definition. So this is the regular, the easiest form of the definition of error. And then a little more complex definition would be the absolute error definition, right? So the absolute error is, of course, the real value or the exact value minus the approximation, but it's going to be inside of the absolute sign or the absolute operation. So in general, the absolute error, which is equal to E subscript A or EA, is going to be equal to the absolute value of the difference between the exact value minus the approximation. Piece of cake, right? So let's go to another one. So the limiting error definition. So the limiting error definition is actually a good example of solving problem solving. Okay. So for example, if I want to say, okay, you know, I have a problem. So I have, it was actually something funny that I did in class when I was teaching the modo presencial. So face-to-face teaching. So for example, let's just talk to, who are you? Tell me your name. So tell me your name. What's your name? Because I don't know your name, sorry. What's your name, lady, in glasses?
Esperanza.
Okay, Esperanza. So I'm gonna try to actually do an exercise with you. So Esperanza, I'm gonna do it in Spanish, okay? It's gonna be easier to understand for everyone, even for the second class. Okay, Esperanza, imagínate que yo te digo, Esperanza, ¿sabes qué? Hoy no traje dinero para comer. Y te digo, oye, préstame 100 pesos. Y tú por supuesto tienes 100 pesos. Y de repente te digo, de repente te digo, bueno, pues obviamente, bueno, es una chica adinerada. Entonces, le digo a ella, Esperanza, por favor, préstamelos. Y me dice, sí, profesor, con gusto. Me los presto y me voy aquí a Soriana, a la picadita esta jarocha, me compro mis empanadas y mi café y pum, me echa ahí mi comida, ¿no? Listo. Entonces, le dije de antemano, te lo pago la próxima clase. O sea, el jueves te lo estaré pagando. Imagínate, el jueves te lo tengo que pagar. Pero de repente yo agarro y saco mi morralla de la bolsa y digo, ¿sabes qué? Esperanza, solamente tengo 80 pesos. ¿Los aceptas y quedamos a mano?
No.
Ella dice que no, ¿verdad? ¿Por qué? ¿Por qué no la aceptas, Esperanza?
Porque faltan 20 pesos.
Exacto, ¿no? Ahora te digo, bueno, ¿sabes qué? Vuelvo a revisar y digo, mira, encontré 10 pesos. Digo, Esperanza, tengo 90. ¿Queda saldada la deuda?
No.
¿Todavía no? Oye, ni porque soy su profe, ¿eh? Bueno, me voy aquí a mi maleta, a mi morral y saco 5 pesos. Y ya tengo 95. Y te digo, Esperanza, 95 y ya queda, ¿no? Porque ya no encuentro más dinero. ¿Tú qué dices?
Órale.
¿Qué dices? ¿Sí?
Sí, está bien. Acepto los 95.
Okay, so now the limiting error for Esperanza is actually 5 pesos. Because that's the amount of error that I am able to forgive. So if you are actually doing a problem, you are solving a problem, and if you have an approximation such as the one we did for the sinus, if you remember the sinus of 5 in radians, sinus of 5, if you remember, was equal to minus 0.9589, right? So that's that was the value of sinus of 5. Assuming that this value is actually the exact value, so I'm gonna now to actually subtract the value of the series to the 17 up to the 17th power. So minus, I'm going to say that this is going to be there, that is going to be plus 0.587. I said that it was equal to 0.0002 to 42.7. So I have an error of 0.0002 in this case. So that and I say, okay, my limiting error is equal to 0.001. So I'm going to use the whiteboard because I want to make this very clear. I'm going to change to the whiteboard. So now let's change a little bit from here. So I'm saying that the sinus of 5 is equal to minus 0.958992. Yeah. So and then the series. So all the series, remember that the series was actually very long thing. Was equal to, I remember it was x, and then plus, I think it was x to the power 3 divided by 3 factorial, and then so on and so on and so on. And then was equal to minus 0.9589. No, 87. So this was with the 17th power. Okay, let's just put it on to the x to the power 17 divided by 17 factorial, right? Something like this. So this was the operation. So and then just before solving my problem, I will use a limiting error of 0.001. Right? This is my limiting error. And then when I calculate the absolute error, so the absolute error is going to be equal to, we said is going to be equal to this, which is minus 0.958992. Sorry, 992. 42.74. I just use the entire. So minus 95.87. So the absolute error is going to be equal to sinus of 5 minus is going to be plus 0.9587, and it's going to be equal to, in absolute, equal to 0.12322.427. So now I could say like this value, or the EA, is less than 0.001. So that's an example of my limiting error. So I'm making sure that my problem actually has a value less than the limiting error. Por ejemplo, Tolentino, Esperanza, ella me dijo, ¿sabes qué? Pues queda saldada mi deuda con 95 pesos, ¿no? Digo, me perdonó 5 pesos. Entonces yo digo que ella dice, ella está estableciendo que con 95 pesos yo estoy saldando una cuenta de 100. Entonces su limiting error de ella sería igual a ¿cuánto? Limiting error is going to be equal to 5. So that's the definition of the limiting error. Okay, do you have any question about this? Okay, if not, if you don't have any questions, I'm going to change back to the screen 2. So now I can say like the limiting error delta x, it's going to be always greater than the absolute error, or the absolute error has to be less or equal than the limiting error. And if you understand the concept, of course, si nos vamos al ejemplo de Esperanza, mi valor que yo estoy aproximando menos mi error, mi limiting error, siempre va a estar en este, o más menos mi limiting error, siempre va a estar dentro del valor real. O sea que yo pude haber saldado la deuda con 95 pesos o pude haber saldado la deuda con 105 pesos. Lógicamente, para mi conveniencia, pues me conviene saldarla con 95, ¿no? Pero también la pude haber saldado con 105 y Esperanza iba a estar más que feliz. ¿Ok? Entonces, si en lugar de tener un error, en lugar de haber tenido un punto 9587, hubiera tenido un punto 9595, en este caso mi error hubiera sido, por supuesto, en este caso. ¿Cierto? Porque ya estaríamos nosotros arriba de nuestro valor. Okay? So that's the concept of the limiting error. So now we have the very simple definition of the error concept. So we have also the absolute error definition, the limiting error, and the last one, it's going to be the relative error. So the relative error, ER, or lowercase sigma, is going to be equal to the absolute error divided by the absolute of the what? Of the true value or the exact value. Okay? So my error with Esperanza was equal to 5. Y el valor real en este caso era igual a 100. ¿Cierto? Entonces sería igual a 5 dividido entre 100. Me va a dar igual a 0.05. Mi error relativo que tuve con Esperanza, en este caso, fue igual a 0.05. ¿Ok? El error relativo que tuve yo en el cálculo del seno, si vimos, era una expresión voy a tener que calcular otra vez, es seno de 5 menos 0.9587. Ah, no, espérame. Seno de 5 es que está negativo. Seno de 5 más 0.9587 me daba menos 0.2 de eso, pues vamos a multiplicarlo por menos 1 para que sea positivo, entre el valor real, que sería en este caso, por supuesto, seno de 5. Seno de 5. El valor en este caso que tengo de un error relativo sería 2.338 por 10 a la menos 4. O sea, es un error bastante pequeñito. O sea, ese sería el error relativo. Es muy sencillo. Si lo piensan bien, es muy sencillo. Únicamente calculan el error absoluto dividido entre ¿qué? Entre el valor real o el valor exacto. So it's a very simple definition. We also have a definition of the limiting relative error, sigma x, but in this case is sigma, lowercase sigma, of a given approximate number is defined similarly as the limiting error. So in this case, the limiting error is going to be exactly the same, but now it's going to be a function of the relative error. But it's going to be exactly the same definition. Okay? And lastly, the last type of error is the percentage error. Okay? The percentage error is actually the relative error times 100. That's going to be the percentage error. ¿Sí, cuánto dije que era el relativo con esperanza? Sí, esperanza, ¿verdad? Tolentino, ¿verdad? Esperanza. Era 0.05. Si lo multiplico por 100, me da un 5%. Un 5%. Entonces, tengo un error de 5%. Si lo multiplico por el error que teníamos del seno de 0.0022 por 100, tengo un error del 0.02%, un error bastante bajo. Pero eso sería básicamente lo que definimos como percentage error. Okay? So, in general, summary, I think in this class we just introduce, well, if we actually talk about the whole class, if you remember, we saw the fundamentals, the basic operations, we saw how to actually analyze a polynomial. We created a very effective way to evaluate polynomials using the Horner's method. Then we moved to a generalization of the Horner's method and the formula. We implemented it in MATLAB. It was successfully implemented. We did at least 3 examples of that. We did this by hand. We calculated the root of this one, and the root was, I remember what, 0.80 something. I don't remember the exact value, but it was about that value. And then we established the exercise that you have to do in this assignment, for this class, sorry. And then we moved to the definition of the errors. We defined the error. We defined the type of errors that we can have in real problems. We did some example of the analytical problems, the errores de redondeo, so very simple definition. And then we defined mathematically the concept of error, the absolute error, the limiting error condition, the relative error, something very simple as the limiting relative error, which is exactly the same as the limiting error for the case of the absolute error. And lastly, we define the percentage error, which is a function of the relative error. And that's it. So that's what I was preparing for this class, guys. I hope you understood mostly everything. And if you have any question, it's time to ask it. Any question? Remember that you will have 1 week after I upload the assignment of the exercises, okay? You will have 1 week to solve it. And you have to deliver it in PDF. It's going to be a PDF file. ¿No más preguntas? ¿No tienen preguntas?
No. No, por favor.
Okay, okay. So I'm gonna actually stop the recording for the other class. So I'm gonna just stop recording, and I have no idea